Hi everyone, welcome to Biogeography Week 12. We're coming in on the home stretch. Just 2 more lectures after this, and the semester will be done. We're finishing up talking about some of my favorite topics: human evolution and migration, and conservation, geography, biogeography, and the Anthropocene. And so I'm really excited about these last couple of weeks coming up. And just to note, sort of like housekeeping and making sure you're staying on top of things, turning in your assignments on time. And if there's delay in those, just letting me know. I'll have a reminder about midterm exam corrections at the end of the lecture. But just make sure you're staying on top of things and email me if you have any questions about when things are due. I try to make that clear in both the assignments and in the lecture. So if there's any confusion about that, before emailing me, just check in on eCampus to see the due dates of things with the course schedule or with the individual assignments. Okay. So speaking of that, the question of the week, there's still a lot of missing responses. So if you haven't answered question 11's question of the week, please go back and do that before you continue with the lecture, because we're going to be talking about some of those answers. So make sure you provide those before finishing the lecture. So if you haven't submitted a question of the week yet, stop the video right now, enter the question, and then come back to this lecture. Okay? All right. So we're talking about human evolution and migration, which has become a much less controversial topic in certain areas, but certainly there's a considerable amount of controversy and disagreement about how this story is coming together. So we'll talk about that. But first, we'll discuss some of the things that are in much less dispute or not disputed at all. Our species' place in the biological tree of life. Okay, so the question becomes about Homo sapiens, or human beings. How old are we, right? What's our lineage? And so a couple of important dates to keep in mind. Primates began to evolve around 65 million years ago, and that date should trigger something in your minds because it was the time when the dinosaurs began to go extinct in sort of relatively quick order. So if you haven't thanked dinosaurs yet, it's a really important thing to thank them, because if they were still around, it's very unlikely that primates would have been able to evolve. Primates don't really do well with dinosaurs, as you can see from the documentary series called Jurassic Park. Another question: what's our most evolutionary primitive extant primate? Right. So another way of saying that is, who are our oldest cousins in the primate family? And the answer to that question is lemurs, this laughing lemur here. So believe it or not, Homo sapiens are very closely related to lemurs compared to other mammal species. They're members of the family. And so there's several major groups of primates. And so the first are the lemurs, the lorises, and the potos. Very cute, fuzzy primates. I have a video on a loris in the on eCampus, so you can check out to see what these primates look like. But they're super cute. Another major group of primates are the tarsiers. There's also a really funny video on the tarsier. They're the only entirely carnivorous primate living today, and they're really interesting. And then there are the anthropoids, a group of primates. And the anthropoids include apes and monkeys. So within that group of anthropoids, bipedalism evolved, but only in apes, not monkeys. As far as human beings know, we have not come across any bipedal monkeys. And certainly in our history, there was a number of bipedal ape species, but now there's only one that we know of. And so bipedal apes, apes that are walking on 2 feet, upright, walking on 2 feet, begin to appear about 6 million years ago. Okay. And so, our lineage as an upright walking ape begins quite a number of years ago. Now, Homo sapiens don't evolve until much later after bipedalism evolves, and there's certainly many more evolutionary developmental steps between bipedalism and Homo sapiens, but that particular characteristic, that unique characteristic, evolves about 6 million years ago in the ape species Australopithecus afarensis. Okay, so we need to get something straight and sort of remind us of our position from a scientific standpoint. And this is a book that was written in the 60s, I think, by Desmond Morris, called The Naked Ape. And this perspective, along with many other indigenous perspectives about human beings, Homo sapiens' place in the tree of life, is really important. And the first thing to understand is that from a scientific standpoint, humans are animals. Colloquially, we like to make that distinction and say that human beings are not animals, and animals are some other class of organisms. And it's important to understand that that is a very Western European concept, and that there are many other cultures and peoples who don't think of human beings as separate from other organisms, or separate entirely from other organisms. There's certainly differences, but we're all classified as members of the community. So we are not the pinnacle of evolution according to science and according to many other ways of knowing. We're just merely a stop along the evolutionary train, and so that's another important thing to remember. Certainly in Western European epistemologies, human beings, and particularly human beings that are from Western Europe, are thought of as the pinnacle of evolution, right? This idea that things don't really get much better than human beings. And that's just not supported by the scientific evidence. It's also not supported by many other ways of knowing. And so for the purposes of this class, it's really important for us to understand that, as we are, Homo sapiens are a stop along the continuum of evolution, and that, our species, our lineage will continue to evolve and evolve into something else, or we will go extinct, like the dinosaurs and like the other hominid species that have existed. But we are not the pinnacle. We are not the best. We are not the most advanced. We are not, any of those things from a scientific standpoint. And then, of course, reminding you of this quote from Dr. Christopher Ryan in the TED Talk, that we did not evolve from apes. We are apes. Homo sapiens are apes. And so, this schematic here, this drawing here, is something that you see a lot of. But, we've talked about how problematic this is. It's sort of showing human evolution as linear and as a singular linear. But I will show some phylogenetic trees that tell a different story. Okay, and so just keeping that in mind, that there are a lot of ways that we're socialized to think of ourselves within this particular culture as human beings that just don't hold up, and they're convenient and they're sort of easy to understand, but they're actually not supported by the evidence. Okay, so if we were in class, I would have this exercise to ask you all to list characteristics of what makes us human, what makes us unique as a species, and we would kind of go through that and talk about it. But I want you to take maybe just 1 or 2 minutes to maybe think of or write some things down that you think are that make Homo sapiens unique. And so, just take a little bit of time to think of and write those things down. Okay. So oftentimes some of the popular answers that I can recall from class are, answers like language or government or technology, or what are some other things? Um, War. And while those things are not prevalent in many other organisms, things like language, technology, warfare, are all things that we see in other organisms. There are whales that have different dialects and different languages, birds that have different dialects and languages. And by language, we mean abstract abstract symbols or sounds that don't necessarily directly translate to their meaning, right? So I'm speaking words to you with different word sounds that have a meaning, but that meaning is not immediately intelligible without being completely immersed within that culture. And there are other organisms that have similar language that are not sort of like obvious things like pointing to my mouth and making a sound for food, right? That's maybe not necessarily language. That's just sort of symbols for things that can be easily understood. But language is a little bit more complex. And human beings aren't the only organisms that have that complex forms of communication based on abstract ideas. Certainly, there are other organisms that wage large-scale conflict against each other. Their social insects are really a good example of this. Government or governance, I should say, is not something that's unique. There are all sorts of rules and regulations that sort of set the social structure for different organisms. We can think about wolves or different social mammals that have these hierarchies and things like that. And so, when we boil a lot of those things down, there's only a couple of things that make human beings unique. And the first is cooked food and the manipulation of fire. And so fire is usually one of those things that comes out in the discussion. And so, cooking our food is something that, so far as we know, no other organism uses. No other organism uses fire to make the nutrients that they ingest more readily available, right? And so cooking food is helpful because it's sort of like a jump-starting the digestion process sort of outside the body. Right, you think about chimpanzees and gorillas and other apes. Their intestines are actually really, really long, and the reason for that is because they require a longer digestive tract to digest the raw foods that they eat. But as human beings evolved to manipulate fire and cook food, we didn't need as much guts to digest our food because we were making it more, the nutrients more available through cooking and processing. So cooking our food is one thing that human beings are, that makes us unique. And then the other that comes out is religion or spiritual, which is religion and spiritual belief are not necessarily the same thing, but this concept of the supernatural realm. Right? Things that cannot easily be understood or experienced or there's evidence for. And the reason why I put a question mark next to religion or spirituality is because human beings understand that this is a quality that we have, but we don't actually know whether or not other organisms have those same concepts. And there's certainly some organisms that have intelligence that we can recognize and relate to, animals like elephants and dolphins and things like that, who are, their intelligence mimics ours in many ways, and certainly other primate species that express sadness when a loved one is killed or died. There are elephants that will, on their migration routes, will have been observed to stop at a site where one of the members of the family has died, and this is many years afterwards, and they'll all just sort of stand around in silence and be still And human beings think that elephants are remembering that family member and thinking about them. So whether or not that translates into a belief about, where that once living relative is where that once living relative might be, we don't know. We're not able to communicate with other species on that level. So we're not quite sure whether or not there are other organisms have those spiritual ideas or those religious beliefs. Okay. All right. So as I mentioned, the story of human beings and our evolution is more than just this drawing here indicates. It's multilinear and many different sort of dead end points where species no longer continue, their lineages no longer continue. And so what I'm going to show you here is a schematic of the many different anthropoid apes that have existed and evolved over time. And so the important thing to note here is, this idea that we've been talking about throughout the semester, that human beings are not descendants of chimps. And we can see that by this lineage of the chimpanzee that broke off from the common hominid ancestor many years ago. And so, there isn't this sort of linear progression of Homo sapiens to chimpanzees. And in fact, chimpanzees and that lineage has been evolving in parallel to ours for the last 4 to 6 million years. And so the other thing to note is all of the different species that we see on this branch that eventually leads to Homo sapiens. And so there were, several different and many different anthropoid apes belonging to the genus Homo. And then we also see another genus, Pananthropus, that had a number of lineages that have now gone extinct. And then we see Australopithecus afarensis and other Australopithecines that are here, right? And so all of this is to show and to demonstrate that the story of human Homo sapien ancestry is complex, and our relatedness is complex, and that complexity is separate from the other ape species that are extant or living today, the chimpanzees, the bonobos, and the other so-called great apes. Okay, so that schematic or that drawing that we had on the last one of this linear progression is something that's been used in popular culture to talk about the general sort of trajectory of human evolution. But again, it's not really the best way to talk about and to represent human evolution, as opposed to this picture here, this phylogenetic tree. All right, so the next couple of things I want to talk about are some of the hominid species that are on our phylogenetic tree. And so what's important for you all to remember about these species that I'm about to list is their relative position, their relative evolution in relationship to Homo sapiens, and their geography, where they are located. And so, on the exam, I might ask a question of which of these hominid species evolved first, or true or false, this hominid species, so far as we know, never left the continent of Africa, right? Those are the sorts of questions that I'll be asking. So let's get started with some of the well-established in the scientific literature hominid species. And the first is Homo habilis, and his nickname is handyman. So habilis meaning hand, or handy tool making. Even though we know now that there are many other apes that use tools and not just our ancestors. And so one of the things that distinguished Homo habilis was the advent of tool making within this particular hominid lineage, and tool making on a scale that had not been observed in the anthropologic record previous. And so Homo habilis evolved around 2.5 million years ago. And in terms of geography, there's no evidence yet that Homo habilis left the continent of Africa. And of course, we know that Homo sapiens and all of these hominid species evolved on the continent of Africa. Some left and some didn't. Homo habilis doesn't appear to have left the continent. Although, as we'll talk about, that the anthropogenic record is changing quite rapidly. And these are just artist renditions of what these hominids might have looked like. Okay, and then we have Homo erectus. Is one of several hominid species living at the time. Okay, and so Homo erectus lived at the same time that Homo habilis lived, and other hominid species. There's a Homo ergaster. Here, there's Homo rudolfensis, another hominid species, and then Homo habilis. So Homo erectus pops up at about 1.8 million years. So it was about 600,000 years between Homo habilis and Homo erectus showing up. And one of the distinguishing characteristics of Homo erectus is that it was roughly the same size as your average Homo sapien is today. And so that's one of the other things. One of the other things that distinguishes Homo erectus is that it began to leave Africa at about 400,000 years ago, that we suspect, and made it all the way to China and Indonesia. And it was the first hominid to show these similar sort of body proportions as Homo sapiens. But there's a lot of debate about the phylogeny, about the relatedness of Homo erectus to the other hominid species that existed at the time, right? And so Homo ergaster is considered a parallel species. But, again, we're getting into like species concept and what distinguishes one species from another. We also know that, the different hominid species that have been identified also live, in similar areas and interbred with each other, right? And so there wasn't that biological reproductive isolation that we see. So again, like, this picture is not quite clear. It's not quite clear what distinguishes one hominid species from the other. And particularly because all of these hominid species were capable of producing offspring, so far as we know. Another hominid species, Homo heidelbergensis, was a cold weather cousin of Homo erectus. All right, and so this hominid species evolved about 700,000 years ago, and it was the first hominid species to build this sort of cold weather structures. And certainly there are other hominid species that built structures as well. But Homo heidelbergensis was one of the first hominid species to exist in cold weather areas, and might have been the first to control fire. There's a lot of debate about that, but certainly surviving in a cold weather climate without fire for a hominid species that's mostly hairless, or not hairless, but has very short hair over its body would have been very difficult. So fire was really important. Another hominid species, Homo neanderthalensis. These are our closest, Homo sapiens' closest extinct relatives, right? So Homo neanderthalensis is no longer around. Evolved about 200,000 years ago in Europe and Asia, okay? And went extinct about 28,000 years ago. So not that long ago, on the evolutionary timescale, certainly. And this hominid species is distinguished from Homo sapiens in being squatter, so shorter and much broader and thicker boned than most Homo sapiens. But again, there was overlap between Neanderthals and other hominid species, and so the lines of what delineates a species versus another is not quite clear. There's lots of evidence that they were intellectually and culturally similar to Homo sapiens. And so again, like, as we move forward in time and closer to our evolution, the lines of distinction become more blurry. So then Homo sapiens evolved in Africa around the same time as Neanderthals, about 200 or 300,000 years ago, and began to leave Africa no later than 800 or 80,000 years ago. Now, we sort of Western scientists used to think that that event occurred much sooner, but I'll talk about new evidence that shows that Homo sapiens had to have left Africa about 100,000 years ago in order to show up in other places in the world where they have recently been discovered or recently been found. And of course, Homo sapiens, interbred with other hominids along the way, with Neanderthals, with Homo erectus, if they were still around, with some of the other hominid species. So, we are a big sort of admixture group of our ancestors, of our ancestral species. So the question would be, for at least Homo sapiens, is why leave East Africa? Why leave that region? Certainly Homo sapiens began to leave before 70,000 years ago. But there was a really dramatic geological, atmospheric, ecological event that occurred about 70,000 years ago, which may have precipitated larger numbers of Homo sapiens leaving East Africa. And that was the eruption of Toba, the super volcano, which is located in Sumatra, in Southeast Asia. And so this is a large volcano that, when it erupted, had a global climate impact. And so when this volcano blew its top, it put into the atmosphere 2,800 cubic kilometers of ash. And so, that's the equivalent of being in a small room and essentially opening a large container of your vacuum cleaner, just throwing all that dust into the air, right? It would cause, and did cause, global ecological, global climate impacts. And so there was this dramatic cooling from all of that particulate matter being released into the atmosphere that certainly had very, very rapid and negative effects on ecologies all over the world. And so the idea is that with the dramatic cooling event that occurred around the globe, that food resources became more scarce, and that would have motivated many different organisms to begin migrating and leaving their current geographies to search for food elsewhere. And so that's the idea that this happened. But, it's difficult, I think, to put into context what almost 3,000 cubic kilometers of ash looks like, right? And so to put that into context, that's enough ash to cover most of the terrestrial surfaces in Southeast Asia with 3 inches of ash, right? So we think about, thousands and thousands and thousands of square kilometers of land covered in 3 inches of ash. That's a lot. That's a lot of particulate matter to put into the atmosphere, and so it had a big, big deleterious effect. And so here's a picture of that mountain, or of that volcano. Many, many, many years later, right? 70,000 years later. And we can see that the crater that was left with this massive explosion has now actually filled in with a lake. It's just sort of interesting to think about these changes and how we get these different structures. But that's what the top of the volcano looks like today. And as far as I know, it's an inactive volcano. But one can imagine that if it were to erupt again, that it would be a really big problem. So when we think about human migration and the 2 hominid species that migrated out of Africa and traveled across the globe, Homo erectus and Homo sapiens were among the most well-traveled species, and certainly Homo sapiens being the most well-traveled. What was the large-scale global driver of human migration? It's likely that there were multiple drivers in multiple migration events throughout the history of those species and any species that exists. Certainly global climate change would have something to do with that. But there are also other reasons, following particular food sources, prey items, things like that. Lots of different reasons why animals migrate. And so Homo sapiens' major achievements, sort of like what distinguishes Homo sapiens from some of the other hominid species, certainly thriving in cold and extreme environments. Homo heidelbergensis was one of the first hominid species to do this, but Homo sapiens certainly took those lessons and used it to colonize and exist in many different cold climates across the globe. And then the other thing that we don't really see much evidence of with other hominid species is Homo sapiens' ability to navigate long distances across large bodies of water. And so, one of the reasons that it's thought that Homo erectus did not begin to successfully venture out into the Pacific and to begin colonizing those islands and eventually the next hemisphere over, was because it's thought that Homo erectus didn't have the intellectual capacity to navigate over those long distances. And you think about, what it would take for, an organism such as ourselves to be able to successfully navigate the Pacific Ocean without any of the modern technology that we would use to depend on it. It takes a lot of knowledge and understanding of the patterns and the rhythms of the earth, and very likely a lot of trial and error that resulted in members of a community, not being successful in doing that. And so, the fact that we appear to see from the anthropologic record that Homo sapiens are the only hominid species to have migrated across these long distances of water is a credit to the evolution of our ability to think through and understand and read our environment. So we come to this hypothesis, the Bering Strait hypothesis, as an explanation for how Homo sapiens got to what's now considered the Western Hemisphere, North and South America. And many of you who've submitted answers used to the question of how did human beings get here through the land bridge that exists between what's now Russia and Alaska. We are socialized to think that that's the case. But, one of your readings for this week and what we'll sort of finish talking about in this lecture is how that hypothesis is problematic. And so, the first thing, of course, it's largely accepted fact amongst Western European scholars. So that's not disputable. I mean, most of us grow up learning that this is how human beings came to, these lands that we occupy right now. But, one of the first issues with this explanation is, and if we're going to be good scientists, if we're going to be good critical thinkers, we have to think about what sorts of cultural biases would exist within the culture that tells us that this is how things happen. And so the Bering Strait hypothesis, first and foremost, comes out of a tradition of Eurocentrism. And Eurocentrism isn't something that is inherently bad or inherently problematic. Most human cultures tend to put themselves at the center or center their stories, their origin stories, as an explanation for why things are the way that they are. The issue with, stories and ideas like the Bering Strait hypothesis and a lot of Eurocentric scientific ideas is that they don't make space for other cultures and other people's own stories about their origins and how they came to be in a particular place. And so it's not necessarily that this particular idea comes from Europe that's the problem. It's the fact that those who perpetuated this idea said that this idea is the correct idea and all other ideas about the origins of how people came to be where they are incorrect. And so that's an issue. The thing then to do or to think about would be, all right, well, what does the evidence point to? And that's sort of like the next step in this idea that, well, okay, it might be a Eurocentric idea, or it might have been developed by people from Western Europe, but the evidence suggests that the Bering Strait hypothesis is correct. And so that's the other issue with this hypothesis, not necessarily that it's a Eurocentric idea, but that that there's a lack of evidence to support that. But just a little bit more about the Eurocentric idea. All men, and emphasis on men and not women, came from Adam. Adam is, of course, European, and that all of humanity is from Europe. So this is a dominant idea. And for those who are not familiar with contemporary ideas about human evolution, might still think that this is true. But of course, we know that our origins from the anthropologic record and from stories in other cultures, that human beings did not originate in Europe, but in fact originated in on the continent of Africa, or what's considered Africa now. And so one of the other issues with the Bering Strait hypothesis, before we talk about the lack of evidence to support it, is that, some of the biggest proponents of this idea that human beings migrated from what's now considered Russia over into Alaska, before there was climatological evidence of this, or the climatological conditions that might support this, many of the proponents of this idea, of this Eurocentric idea, were notoriously anti-Black and anti-Indigenous. These were people who firmly and staunchly and oftentimes violently believed that people from Europe, and eventually what came to be considered as white people, were superior in every way to people who were considered Black and Indigenous people, right? And so, it's important to take a critical look at the basis of an idea, where it comes from, and what sort of cultural influences that that it might be subject to. What's the culture of the general story of the idea that it comes from, and then who are the people who are pushing this idea. And so the establishment of the Bering Strait hypothesis as fact was established by people who were incredibly biased against an alternative idea that humanity originated in what would be Black people or Indigenous people, right? So those are kind of like the social science issues with this hypothesis. So now let's discuss the evidence, right? The physical evidence, or the anthropologic evidence, which is also shaky. And so, the issue with many Eurocentric ideas in the mainstream is that they don't leave space, or don't even consider the collective histories of Indigenous people as valid, just right off the bat, right? And so there's lots of evidence within the linguistic field, when we look at the families of languages, and just like families of languages resembling relatedness in the same way that different species resemble relatedness, when we look at the language differences between Indigenous people that share very similar geography, we see lots of differences, and that would be the result of multiple colonizations and not from a common ancestor. So if we think about the language, the so-called Romance languages, they're all Latin based, right? The similarities between Spanish, French, and Spanish, French, and Italian are very similar, right? And it just so happens that the origins of those languages share a geography. And so we would say that, the language of many of the areas of Western Europe come from Latin, right? And we can trace that. But when we look at the language structures of the different indigenous people in this part of the world, we see that there's a much greater difference between neighboring languages or neighboring cultures than we would expect if there was this one common ancestor that colonized or came to North America. So the linguistic evidence doesn't support this one migration of human beings and then the expansion of those human beings from north to south that we would expect looking at the language. And so, there's a quote from an anthropologist: "The unmistakable testimony of the linguistic evidence is that the New World has been inhabited nearly as long as Australia or New Guinea." And that would be at least 80,000 years ago, right? So this is a linguistic anthropologist that put that. And so the physical evidence is that, humans on Turtle Island. So that's the name that many indigenous people give what we consider North America. They call it Turtle Island. And there's an origin story about that. That you can read up, is that the evidence, the linguistic evidence, suggests that human beings have been on these lands for at least 35,000 years, which is different than the Bering Strait hypothesis, which suggests that human beings migrated to Turtle Island about 14,000 or 15,000 years ago, right? So 20,000 year difference. And I mentioned before that the physical evidence of one sort of migration of human beings across the land bridge is also not supported by the physical evidence, the anthropologic evidence. So one, and this is the the biggest issue, is that the climatological evidence shows that about 13 to 15,000 years ago, the Bering Strait was not covered in ice. So there was not a ice bridge or a land bridge that would have connected the two hemispheres, right? So human beings couldn't have migrated across that, at least not by the land bridge. Now, we might argue that that human beings use boats to migrate across. But if we're going to say that human beings use boats to cross that space, then we have to wonder why would they have used their boats to cross that amount of space and not other colonizations in other areas. If you look at the South Pacific, there are many, many, many different islands that would have made it relatively easy to hop from island to island. So if human beings can migrate in the northern hemisphere, why not in the southern hemisphere to reach these islands? And then the other physical evidence is that we see crops like corn and other things that are endemic to, like potatoes and tomatoes, that are endemic to North America in the South Pacific. And so, in areas like Tahiti and these other areas that we know human beings have existed, we see plant species, food species that are only that we know evolved and are endemic to what's now considered South America. Right? And so the only way for those crops to be present is if human beings were moving from this continent that we're on right now, or South American continent, back to more ancestral islands in the South Pacific. And then, of course, there's a lot of talk about DNA evidence of that supports this one migration that we see. But one of the other readings, or one of the other listenings that you're going to have for this week, is an interview with an indigenous scholar by the name of Kim Tallbear, who literally wrote the book on native DNA and all of the issues with DNA science and how it is deeply problematic when we try to assign characteristics of being indigenous to one's DNA, right? And so, there are a number of takeaways from this Bering Strait hypothesis and just human evolution in general and migration in general. The first is that we're still learning quite a bit every year. And by the we, I mean those situated in Western science. There's evidence of human beings in Australia from 80,000 years ago, Homo sapiens from 80,000 years ago. So again, that sort of pushes the timeline back a bit. We still, and again, the we meaning people who are situated within Western science ideas. We still are struggling to unlearn the racist biases that are baked into Western European scholarship, right? That's something that's undeniable. There's evidence of racist bias and sexist bias throughout the fields that we are studying, that we are being exposed to. And there's still a tradition of indigenous knowledge being dismissed as folklore and superstition and not actually grounded in physical evidence or grounded in a body of knowledge that's considered legitimate. And there are all sorts of issues with that, but that's something that those of us who are not indigenous and were not grown up on these stories need to be aware of. And so, the indigenous knowledge is not valued as empirical knowledge, right? It's something different. It's a story. So therefore, it can't be used, or it can't be understood as truth or scientific truth. But many indigenous stories, many indigenous understandings and ways of knowing are supported by the physical evidence. So, and many of the indigenous stories and knowledges and cultures are physical evidence that we would understand as science. And so non-European people are never considered as smart as Europeans, the European people who discover them. And there's a long tradition of this that is still present within science, right? There's a hierarchy of knowledge, and there's a hierarchy of who has legitimate knowledge and who has to work a little bit harder to demonstrate that they are experts. So, our concepts, and again, the our and the we being people who are raised in sort of these Western European ways of knowing, is going to continue to expand and to understand once we do a better job of removing our biases and being aware of our biases, but also, the new physical evidence that we are discovering and learning to listen to indigenous people about, more and more each year. So, the last takeaway, which is not listed here in the bullet points, I'll just say, is that the Bering Strait hypothesis is not well supported, which is why I'm not calling it a theory. Because of the scientific evidence doesn't support it. And that it is, the Bering Strait hypothesis is deeply problematic. So if you learn nothing else from this class or from this particular discussion, is that idea, that hypothesis is not well supported. And, one of the readings that I've assigned this week outlines some of the things that we talked about in this lecture. So the next thing that I want to do is kind of have this juxtaposition here, because I want to just briefly talk about, and this will lead into our discussions on conservation and the Anthropocene. I want to briefly talk about, the differences in these two photos and what they represent. And so, there's a really stark inflection point, I like to call, that happened in human history and happened in multiple locations in human history that brought us, our species, from something that was visually understood and environmentally understood in the photo on the left of this man who is an indigenous person in the sort of Southeast Asian, what's now considered Australian, Papua New Guinea area, to a way of existing on the landscape that we see on the right with this farmer and the technology that we see and the means of production that we see here. So this farmer, it looks like what's standing in a soybean field. And this is a really important societal shift that we see that occurred. So for the majority of human history, human beings existed as hunter-gatherers, subsistence agriculturalists, in a way that would be very unrecognizable for most of us living today. But of course, we see this large-scale shift to agriculture, and a particular type of agriculture that began around 15,000 years ago. So now we're talking about, industrial agriculture. So we're talking about civilizations like, the Egyptian civilization, Mayan civilization, Aztec civilization, Mesopotamia, these different civilizations, where hunting and gathering is less and less a part of subsistence, and agriculture becomes commerce. It becomes economy, which is very different. And so what happens in the societal shift around 15,000 years ago, we see this rapid cultural extinction of indigenous people. And that's because of the industrial agricultural practices. So why is, this new societal shift that we see in multiple areas around 15,000 years ago in our history, why is it an anti-indigenous civilization? Well, an anti-indigenous civilization I'm defining as a form of subsistence and economy, right, that is completely dependent on domestication of life. Right? So we're talking about industrial agriculture, industrial level husbandry of livestock, those sorts of things. And so, this form of subsistence leads to the formation of cities, right? These big, dense concentrations of humanity and resources. And these cities continue to grow, the populations continue to grow, and they continue to demand resources from outside of these metropoles, right? So we get these stagnant settlements. Human beings aren't really migrating through the landscape and moving with the ecology. They are trying to change the ecology to fit their needs. And so there's many examples of anti-indigenous civilizations: Egypt, Rome, the United States of America. This has been a dominant way of living on the planet for the last 15,000 years. And there's been all sorts of impacts from this way of living. So why anti-indigenous? Well, when we think about empire and the establishment of empire and the building of empire and the maintaining of empire, a lot of it is about controlling people, right? And so the autonomy of those on the outside, the so-called barbarians and the uncivilized people, the savages, we begin to see this language where those who live within these cities, live within these nation states, begin to look down on others. And so, this idea of anti-indigeneity became ensconced in this document that came from the Catholic Church called the Doctrine of Discovery. And so there's a video that I will post here that talks about the Doctrine of Discovery. And it's essentially a document that was established that any Western European nation and any nation that was affiliated with the Catholic Church, if it came to a land and they were indeed people, human beings that were there, those people who were not Catholic or were not Christian did not have a right to those lands. And therefore, the Christians and the Catholics who claimed those lands could do whatever they wanted with the people there and the resources that were there. And this Doctrine of Discovery is an awful precedent in terms of maintaining and respecting the autonomy and the sovereignty of other peoples. But what's interesting about the Doctrine of Discovery is that it's still used today. It is the primary basis with which the United States of America has staked its claim to lands here. And many other nations who have staked claims to land and people and resources. And it's such a powerful precedent, it's such a powerful document that it's still used today in Supreme Court cases. The Supreme Court of the United States of America this century, in the last couple of decades, has actually invoked the Doctrine of Discovery for the ongoing disputes between the settler state of the United States and indigenous people, right? And so this is a really important document, but also one that many indigenous people and cultures view as monstrous because it has been used to justify their extinction, right? And so, the idea essentially is those people will assimilate, right? They will join this growing nation state, or they will be removed. They will die. And that's really the long and short of it. a really unpleasant element of the history of many different civilizations. But if a civilization is going to demand and stake claim over resources outside of their geography, then they have to have some justification for it, even if it is not really morally defensible. And so, what happens also, not just to the human beings, but the land is transformed beyond its capacity to sustain human populations. So we see that anti-indigenous civilizations, so civilizations that are bent on mass production of just a few domesticated species, only last about 3,000 to 4,000 years, and then they collapse. They deplete their resources. The demand of resources outside their borders and the movement of those borders results in large-scale conflict, what we understand to be as war. The density of people and resources also results in disease. So these are the things that sort of lead to the collapse of these civilizations. Another aspect of anti-indigenous civilizations, and one of the most consistent things that signals its collapse, is the loss of topsoil. So we think about the industrial agricultural practices of the modern times. One of the things that these lands are losing, because the production demands are so high, right? Because our economies are dependent upon producing lots of corn, lots of rice, lots of wheat and soybeans, is that the land can't sustain that level of production, and so we are losing topsoil at a very, very rapid rate. And topsoil is the thing that we need to grow the food that we have. And so, when we track topsoil loss in some of the more recently collapsed anti-indigenous civilizations, we see that it's about 3,000 to 4,000 years. That's how long you have to run a deficit of your topsoil, and then you just can't provide the food to your people. Okay, so we'll talk more about anti-indigenous civilizations when we talk about the Anthropocene, when we talk about conservation, because it's directly related to this very dominant and new way of living on the landscape for human beings that is anti-indigenous, which is not sustainable, and results in the cultural and species extinction of many, many different human and non-human relatives. Okay, so question of this week: if you could save one group of organisms, right, flowering plants, carnivorous mammals, flying insects, not just one species, but sort of like a group of species, if you could save one of those groups of organisms from extinction, what group would it be and why? Right? So that's the question of the week. I'm curious to know, in thinking about conservation, what sorts of organisms are on your mind or come to your mind that you feel connected to, or that you feel are important to save. Okay. All right. So reminders for the week that you will have a new reading and a new podcast, and those reflections are not due until the Friday after next. Right. So I'm posting this lecture on Wednesday. So those reflections and that podcast reading won't be due on the 13th of Friday, but they'll be due the following Friday, the 20th. So you have about, 9 days to read and listen and to fill out or to answer the questions on the reflections. Okay, so be on the lookout for that. But what is due this Friday, for those of you all who decided to submit your midterm exam corrections, those are due Friday by the end of the day, so Friday the 13th. So please make sure you have gotten a copy of your exam with the which indicates which points you missed, and particularly for the essay questions, how many points you missed. All right, that's going to be really important for you to recoup some of the points that I'm offering. So please make sure you follow the directions for the midterm exam corrections to the letter. I think I'm going to end up regrading at least half of the midterm exams, and so it's really important that you follow the directions so that I don't have to spend any more time than is necessary in making sure that you can earn your points back. If you don't follow the directions, right, and they're very specific, if you don't follow the directions, I'm not going to regrade your midterm exams. Okay, so I'm doing something extra, going a little bit above and beyond to offer these points because I recognize the particular conditions that we're under, and that the exam is challenging, and not necessarily you're not necessarily receiving the same interaction that you were hoping for because of the pandemic. So if I'm going to spend the extra time to do this, then you need to make sure that you are following the directions, because I can't I simply don't have time to check your meanings of the answers to the questions if you don't follow the directions. It just makes it a lot easier for me to run through and grade these quickly and allow you to earn the points back. So please follow the directions, double check, triple check, so that you can get your points. Okay. All right. So that's all I have. Be back next week with a lecture on conservation, which is even more my specialty. So that'll be fun to talk about. And just send me an email if there's anything unclear about what's due, when it's due. But first, check the schedule, check the eCampus boxes, and if there's things that are still unclear, then just let me know. Okay? Alrighty. Talk to you all soon.